And then what's going to go in here for x? 3. So put 3, 3, 3. Okay? So now the square root is like the order of operations, right? It's like parentheses. So what are we going to do first? We're going to simplify inside the radical, right? Because that's like parentheses. So we're going to square first or multiply first? Square the 3, right? And that becomes a 9. Plus 7 times 3 is 21. But we can't take the square root of 9 because of the plus. If this is 9 times 21, if it was like this, 9 times 21, we could say, all right, square root of 9 is 3. And so that's 3 square root 21. But we can't do that when there's a plus because because it's like the order of operations. You have to simplify inside the parentheses. This would be considered, simplified. You could break that up and simplify it. So we have to add, right? 9 plus 21 would give us a square root of what? 30, right? And so 30 is, if we looked at 30, 30 is 5 times 10, and 10 is 2 times 5, or 5 times, not 5 times 10, 6 times 5, right? 5 times 6, so that's 2 and 3, right? So you don't have anything you can get an even square root out of. So this is your answer here, okay? Well, if you can get two numbers, right, that are the same, like if you had 50, like if you had the square root of 50, okay? Well, 50 is 5 times 10, right? And 10 is 5 times 2. So this is like 5 times 5, right? It's like doubles, right? That's the same thing as if you said 25 times 2, right? Well, you can get an even square root out of 25, right? So that would be 5 square root 2. So you want to break it down into what we call prime factors, and then see where can we get doubles to get an even square root, okay? All right, any other questions there? Okay, so that's that one. All right, number 2, find the domain of a function. Let's go over domain real quick. So let me just write this question down. Here we have f of x equals to x minus 3 over 3x minus 5. Okay, we want to find domain. All right, so let's review domain real quick. With domain, we can assume this a domain is all real numbers, okay, except two cases. What's one of them? When x is what? In the radical, right? Except when x is in the radical. Yeah, that's right. And the other one is when x is in the denominator. When x is in the denominator. I'll just abbreviate denominator. So that would be like y equals to 1 over x. If x is not in either one of those cases, then the domain is all real numbers. So, looking at our function, do we have our function in one of these two categories? Yeah, when x is in the denominator, right? X is in the denominator here, 3x minus 5. So we don't have all real numbers, right? So in that case, when it's in the radical, we set x to greater than or equal to 0, then solve. When it's in the denominator, set x equal to 0, then solve. Okay? So if it's in the radical, we set it to greater than or equal to 0, then solve. Here, if it's in the denominator, we set it to equal to 0, then solve. So what are we going to do here? Yeah. Yeah, you're going to take the 3x minus 5, right? Yeah, go ahead.
Number 2 is different from my opinion.
2. Oh, hold on a minute. What now? 2 is find the domain. Oh, 3x, x squared minus 4. Okay. All right. Okay, I got the wrong one, don't I? All right, we'll fix that. Okay, so it's 3x over x squared minus 4. Okay. Okay, so x is still in the denominator, right?
Mm-hmm.
So we got to set, so what do we do here? We're going to set it to greater than, so we know that it's not all real numbers, right? Because x is in the denominator. So it's not all real numbers, so it fits in the second one, right? So what do we do to find the domain here? Take x squared minus 4 and set it equal to 0, right? So we take that denominator, x squared minus 4, set it equal to 0, then solve, right? Well, we can do this one of two ways. We can either factor it, or we can use the square root method. So which way do you want to do it? The easy way?
Yeah.
The easier way would be the square root method. So what's even easier is if we get off all the cell phones, unless you're using the calculator. So can we, do we need to take the cell phone out in the hallway? Miss? Ma'am? Do we need to take the cell phone out in the hall? Appreciate it. Okay, so we're going to take, we can use the square root method. So if we apply plus 4, and then we have x squared equal to 4. Okay? All right. Well, we still have to isolate that x, right? So this is known as the square root method. You can only use this if you have a difference of two squares, where there's an x squared and then just a number squared. So here, what can we do to get rid of that square? Apply the square root. Apply the square root. But what do we need here? Yeah, plus or minus. Good. Without it, you only have one solution. Okay, so the square and the square root, they cancel out, right? And so we get plus or minus, the square root of 4 is 2. So if we look on the number line, we've got negative 2 and we've got positive 2. And so if we put negative 2 in here, negative 2 squared is negative 2 times negative 2 is 4. 4 minus 4 is 0. We get undefined. So that's undefined there. And if we put positive 2 in there, we get the same thing. We got 4 minus 4, we get 0, we get undefined. So your domain exists everywhere. This is wonderful. Everywhere except those two numbers. Okay? So, let's see, in the answer, do they use interval notation? Oh, okay. In the answer, they use set notation. So, in the answer would be domain is a set of all values of set x such that x does not equal to positive or negative 2. And that's our domain. Hold on a second. We may have to move. Alright. I'll answer your question and then we're going to move. That other classroom is empty. Okay, what were you saying?
How do you know it's an open circle? How do you know it's an open circle?
Oh, well, it's an open circle because you get, if you have x in the denominator, they're all open circle. Okay? They're all open circle. If x is in the radical, then it's closed. Then it's greater than or equal to. So if x is in the denominator, it's going to be an open circle. So there's two ways that you can write the domain. One is to put it in set notation like this, and the other one is to put it in interval notation, which is probably more like what you're used to, where you have open at negative infinity to negative 2, it's open at negative 2, and then negative 2 to positive 2, and then union 2 to infinity, and again open at infinity. So this is probably more like what you're used to, and it really depends on the textbook which one they tend to go with. The set notation one is actually easier to identify because you just take what you had for your solution and you just put it in the brackets and you just put not equal to. The interval notation is a little bit more involved, but either one of these is equally correct to illustrate. It just depends on which way the author wants you to write it. Okay? All right. Maybe we won't get any more drilling back there. All right. 3. Find the intercepts, the y-intercept. How do we find the intercepts here? Let's go over the intercepts. Okay. Let's say that we have a rational function. Here's a graph. And we have a rational function that looks something like this. And something like this maybe. Okay? And you have a y-intercept here. Well, the y-intercept, x has to be 0. We don't know what y is, but we do know x is 0. So we've been using a table of values, right? Set x equals 0, solve for y. And for the x-intercept, we don't know what x is, but we do know y has to be 0, right? So we put y equals 0 and solve for x. So that's how we find the x and y intercepts for any function. whether it's a parabola, whether it's linear, whether it's a parabola, whether in this case a rational function, radical, it's the same with all of them. Okay? So in this case, we want to find the y-intercept. Now the y-intercept is the easiest one out of all of them to find, because really all you have to do is cover up the x's. And what's left over? Your y-intercept. Okay, so in this case, it's what? Yeah, so in other words, you're putting 0 where the x's are, right? So we have f of x is equal to x minus 3 over 3x minus 5, okay? So we put 0 in for x, find y, right? So wherever x is, we put a 0. So that's 0 minus 3 over 3 times 0 minus 5. And so the zeros, they go away, right? And what's left? Negative 3 over negative 5. Well, negative divided by negative is a positive. And so our y-intercept is x is 0, y is 3 over 5. And that's our answer. Okay? That's all they wanted us to do. All right? Questions? Okay. No, you don't have to graph. That's all they're asking for. I did the graph here to illustrate why x has to be 0 at any y-intercept. Okay? X is always going to be 0 at any y-intercept, whether it's up here, here, at the origin, anywhere. Negative, x has to be 0. Okay? Anywhere you have an x-intercept, y has to be 0, whether it's here, 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 origin, anywhere. Y has to be 0 at x-intercept, at any x-intercept. Okay? All right. Any other questions? Good questions. Okay, find the x-intercepts. All right, so let's do that one. Okay, number 4. We have f of x equals to x minus 2 over x squared plus 6x minus 2. Okay. All right. So we want to find the x-intercepts, right? So what are we setting, putting 0 at this time? Where the y is, right? Well, y is equivalent to f of x, right? F of x and y are the same, right? So if we said y equals 2x minus 2 over x squared plus 6x minus 2, it means the same thing, right? Well, where's the y? Where's the 0 is going to go where the y is, right? So we take the y away, we put 0 there. Okay, what's the first thing we always do when we have a denominator and we're trying to solve? Multiply out the denominator, right? We multiply out the denominator. So we take this whole denominator here, right? And we say times x squared plus 6x minus 2 times x squared plus 6x minus 2. And they cancel. Okay? Well, anything times 0 is what? 0. So this is still 0, right? So 0 equals to x minus 2. Now this happens every time, okay? So if you see a rational function like this, you can always say, all right, and I know I got to put 0 in for y, right, or f of x. And I know when I multiply, this denominator is going to go to 0. So I could just, you can skip, you can go straight from here to the third step, okay? And say, all right, I know that the denominator, I said the denominator equals 0, is the same thing as the denominator canceling out, going to 0. Okay, so now what do we do?
Add 2.
Plus 2, plus 2. Okay, so we get x equals to 2. So therefore, our ordered pair this time is what? 2, 0. That is correct.
So
that's our x-intercept. So there's only one x-intercept.
in what case did you do what you just did? You how you multiply the denominators?
Yeah, you multiply out, so you do that anytime you're solving, right? You have to multiply out the denominator. So because this is all one polynomial, you have to multiply that all out as 1. You can't do it separately because of the plus and the minus. So you have to do it all in one unit, right?
You want to do that when you have an x in the denominator?
Yeah, when you're looking for the x-intercept. You do that when you're looking for the x-intercept. Okay? Well, like I said, because the denominator gets multiplied into 0 and goes away, you could just go straight from our original equation and just set the numerator equals 0. And textbooks teach that, okay? But the reason why that works is because the denominator gets multiplied into 0 and it goes away anyways, okay? All right, so any other questions there? Good questions. Okay. Find the domain. So that goes back to our previous problem, right? We ask ourselves 2 questions, right? What do we ask?
Is x in the denominator or in the numerator?
Yeah, is x in the denominator and is x in, or is x in the radical? If it's not, then the domain is what? All real numbers. So the domain here is all real numbers. Okay, good. Any other questions there? All right, that's easy. There's the rest of this. Why is this not loading? All right, there we go. Why is this not? Oh, maybe I got to do that. Back up. All right, I'll just use this paper. It just makes it easier. I don't know why that's not loading. Okay. Hold on, let me try something here. There we go. It's still not working. Oh, I see why. Okay. That's better. Okay. Okay, for the given function, f and g, find the requested function and state its domain. Find f. So what does this dot mean? Multiplied, right? So do we need to go through, basically all you're doing here is foiling, right?
Yeah.
So when you FOIL, right, if you don't get x in the denominator and you don't get x in the radical, then the domain is what? All real numbers. Do we need to see number 6? Or are we okay? Okay. For the given function f of g, find the requested function state its domain. Okay, here we want to do what? Subtract, right? Let's. What?
So you have to be careful with the subtraction sign because it can also turn into a negative. Like you put in parentheses 6x minus 2 minus 2x minus 4.
That's right. What he's saying here is you've got to be careful when you're subtracting because the minus sign has to be distributed into the whole second term. So you use parentheses 6x minus 2 minus parentheses 2x minus 4 to distribute that negative. That changes the signs of the 2x and the minus 4. The 2x becomes negative, the 4 becomes a positive. And then, so then you either add or subtract back based on the signs. Do we need to see that one? We could? Okay. Okay, use the slope and the y-intercept to graph. So basically here we're just using slope-intercept method, right? Do we need to see this one? Good. Okay. All right. Oh, I'm seeing it. That's shaking no, so that's a good sign. Okay. Determine algebraically whether the function is even, odd, or neither. Okay. Let's look at that one. So basically, let's review that process real quick. Okay. To determine if a function is even, odd, or neither. If a function is even, if we substitute in negative x into the function, okay, and no signs change. If we substitute negative x in to the function and no signs change, then the function is even.
What do you mean by sign? Like the signs?
Yeah, if the signs to the function. So, and then let me do the other one. So that's even. Odd, if you substitute negative x in to the function and all signs change, then the function is odd. It's an odd function. So this is an even function. If we substitute negative x in and some signs change and some don't, or some don't change, then it is neither even nor odd function. Okay? So if you substitute negative x in, and it looks the same as that you started with, and the book illustrates it as f of x, f of negative x, equal to f of x. In other words, no signs change. It looks like the original function. If you substitute negative x in and you get a negative in front, this means all signs change. In other words, the negative was it's like the negative was distributed in the function and all the signs change. And then here, if negative x is substituted in for x, and some signs change and some signs don't, then it's neither. So if we look at our function, our problem, I believe it was 8, right? No, 9. Problem 9. We have f of x equals to a negative 2x squared plus 8. Okay? And so it's like we're cutting out the x. We cut out the x, put parentheses. Cut out the x, put parentheses. So this is f of parentheses equals to negative 2, and in parentheses squared plus 8. So we cut out the x and we put parentheses. And then we're going to substitute in negative x inside parentheses. Substitute negative x, substitute negative x. Okay, the order of operations tells us that are we going to multiply or apply the exponent first? Exponent comes first, right? So basically, this is like negative 2 times negative x times negative x, right? So negative x times negative x is a what? Positive. So that comes out positive x squared. So that's negative 2 times x squared plus 8. So so you compare it to the original function. So which one of these three scenarios, which one of these three, even, odd, or neither? So did no signs change, all signs change, or some signs change? No signs change. So therefore our function is even. That's our answer. Okay? Questions? Alrighty. Okay. So problem 10. The graph of a function f is given. Use the graph to answer a question. Find the number, if any, at which f has a local maximum. And what are the local maxima? Maxima is plural for maximum. So if we have more than one maximum, then it's a maxima. All right. So do we need to go over this one? Or okay. The maximum is the y value. It's located on the x value. So in this case, the maximum is what? 2. The maximum is 2. But it's located at negative pi and positive pi. Okay? So the maximum would be 2 at negative pi and positive pi. Okay? Questions? So the minimum would be what? They don't ask for the minimum, but we'll do it. Yeah, negative 2 at, what's x? What's x here? Didn't go right, didn't go left. X is, yeah, the local minimum is negative 2 at x equals, didn't go right, didn't go left, so x has to be 0. Good. So the local minimum is negative 2 at x equals 0. Okay?
So in this case, you put
so there's a couple of different ways to answer this. Okay, you could use ordered pairs. Let's see, this is 10. Okay, so they wrote where it's at first. They said it's located at, the local maximum is located at negative pi and positive pi. But the local maximum is 2. Okay, so they wrote they wrote the location first, and then the actual maximum last. All right, but it's all the same answer. Okay, good responses there. Find the average rate of change between the given functional values. Okay. So, questions here.
Don't we have to plug in each one of them?
Yeah, you have to use this equation. You have to use, oops. Yep, you got it. The average rate of change, and I believe they use between, right? Oh, okay, from A to B, okay? From A to B is f of B minus f of A over B minus A. So basically, you're given X values, right? And in this case, you're given 0, I believe it was 0 and 2, right? 0, okay. So we're talking about from 0 to 2 for the function f of x equals 2x squared plus 5x, okay? So basically, you're given two x values in a function. So what you have to do is, all this really is the average rate of change is really nothing more than slope. If you were to graph this, okay, and it looks something like this, it's going to look something like this, right? And we're saying we want from 0 to 2. And this is going to be a curve. There's going to be a curve in this. So you're looking at, if you were to draw a line, we want to know the average rate of change. We want to know, basically what we want to know is the slope. The slope, if we were to draw a line on this curve between 0 and 2, we want to know what is that slope? What is the average rate of change? So really all this is this slope of 2 points equation, okay? Where you put, in this case, we're looking for f of 2 minus f of 0, right? 2 is our b, and 0 is our a, over 2 minus 0. Okay, that's what we're looking at. So if you were to find what f of 2 is, right, all you're doing is substituting that into this equation, right? So that would be 2 squared plus 5 times 2. So 2 squared is 4, right? 5 times 2 is 10. So that would be 14. Okay? So this will be 14 here. So we find what f of 0 is next. So this will be, and now we're going to put 0 in here, squared plus 5 times 0, and what do we get out? 0. So that'll be 14 minus 0. Okay, so we put 0 here where f of 0 is. And then 2 minus 0, right? Because we're just putting these values in, but you got to put b minus a in, right? So that becomes 14 over 2, which is our average rate of change is what? 7. So what this means is our slope from between these 2 points on this curve is 7. Up 7, right 1. Okay, so that's a pretty steep slope, right? So that's all the average rate of change is slope. Okay? Questions there? Did you have a question? We good? All right. So, all right. and for all those of you that are going on to calculus, you'll see that again, all right, for sure. And that gets into differentiation and all that. Okay. Write the equation of the function has the given characteristics. The graph y because absolute value of x shifted 7 units to the right. Do we need to see that one? Yeah. Yeah. So you're going to write the equation. So where's the step 7 going to go? Is it going to go inside or outside the? Yeah, inside. Yeah, it's going to go inside the absolute value. Is it going to be a positive or a negative? Negative, right? X minus 7 inside. All right. Do we need to review that? Or are we okay? The transformations? Okay. All right, good. Okay, graph the function given, determine whether the function is increasing, decreasing, or constant. So basically, and you're looking between -3 and -3 halves. So here's negative 1, -2, -3. So you're looking at from here to -3 halves, which is, here's -1, so -3 halves would be just to the right of that, a little bit less of a negative. So we're looking at this interval here. Okay. So do we need to go over that? Okay. We look at the interval for the x values, but we look at what y is doing. So is y increasing or decreasing between the interval of -3 and -3 halves? It's decreasing, right? So that's our answer, decreasing. But let's go a little bit further. How do you know what?
How do you know that that's the one looking? Like you said, they're looking at that particular side.
How do we know that we're looking at? Because they give you this interval. Okay. So how do we know what we're looking at? Well, they give you this is basically like the domain, right? This is the x interval. These are your x values that you're looking at from -3 to -3 halves, okay? So let's say that we wanted the interval from -3 halves to 0. Now what's the function doing? Is it increasing, decreasing, or constant? It's increasing, right? So where else is what other interval is the function increasing? Let's say this is 1 1/2. Let's say this is 1 1/2. Yeah, so it's going from -6 to 6, right? At an interval from -1/2 to 3, it looks like. So we would write it as -1 or 1 1/2 or 3 halves, positive 3 halves to 3. It's increasing. Okay. Questions there? Okay. Solve. Do we have inequalities? Do we need? This is the last part of chapter 3. Yeah. In other words, you're solving so this would be, instead of f of x equals 0, you're going to put in here -x minus 4 is greater than 0 and then solve. It's greater than 0. Yeah. So in other words, let's look at that one. So in other words, you're taking the function and you're substituting in, so you've got f of x equals to -x minus 4, right? And g of x equals to x minus 15. And you want to solve for f of x is greater than 0, right? So basically, you're just taking this equation and you're putting in where f of x is. So this would be negative x minus 4 is greater than 0, and then you're going to solve. Okay? So what do we do? Yeah, okay. All right, plus 4, and so this will be negative x is greater than 4, but are we done? We're not, right? It's not simplified completely. So what do we got to do with that negative? We can, yeah, you can either multiply or divide by negative 1, right? I like to divide because negative divided by negative is a positive. And so what happens to that inequality sign? It flips, right? X is on the large end, now x is on the small end. Positive 4 divided by negative 1 is a negative 4. So here's negative 4. Is the solution going to the right or to the left? Less than. Yeah, it's going to the left, and it's less than, not less than or equal to its, so is it open or closed? Open parentheses to the left of negative 4, where we got an arrow because it keeps going. And whenever there's an arrow, we use negative, in this case, negative infinity, right? Because it's going towards the negative numbers. So let's see the solution. Let's see if they use interval or set notation for which number is this? 14. Okay, so we're done here. We're done here. They don't want you to put it in any other form. Okay, so any other questions there? All right, so g of x, same thing, right? Solve f of x is less than or equal to g of x. You basically substitute negative x minus 4 in for f of x, x minus 15 for g of x, and then solve for x. Do we need to see that one? We good?
I don't see it right.
How you would write it? Okay. So basically, you want to solve for f of x is less than or equal to g of x. Okay, so basically, wherever f of x is, it's like you're cutting out that f of x, okay, parentheses, less than or equal to, where the g of x is, cut it out, and then you're going to substitute in the equation for f of x, which is negative x minus 4, and for g of x, x minus 15. Since there's nothing to multiply or square or anything like that, you can just drop the parentheses. X minus 4 is less than or equal to x minus 15, and then solve from there. Okay? So we good? We need to go further?
No.
We're good. Okay. Awesome.
You get x to the side.
Then you get x is greater than or equal to or less than or equal to some number, right? Okay. Now the thing to remember, one other thing here, okay? So let's say if you were to add x, right, and you get 2x minus 15, and then here you get negative 4, and then add 15, right, plus 15. And so 15 minus 4 is 11, right? 2x, and then divide by 2x, and you get x is that, right? Okay, now, on the distractions, you've got less than or equal to 11 over 2, x is greater than or equal to 11 over 2, and you got others, so this is A and B and C and D, something else. Which one of these is the solution? X is on the large end. X is on the large end. Yeah, it's B. So these are considered equivalent, like, because you can switch everything, right? So the thing you got to look at, if you solve for x on the right side, okay, you got to be careful that you got to look at that inequality sign, whereas x on the large end or the small end, and you got to look at it here, where's x on the large end or the small end. That's why you have to switch. That's why when you multiply or divide by a negative, you have to switch that inequality sign, because you have to have the same answer whether you have x on the right or the left side. Here we had x on the right, so we didn't end up with a negative x, right? So we didn't have to switch the inequality sign because x switched sides, right? So be careful with that, all right? Okay. Number